Hey peoples, so I've been wanting to build a quadcopter forever, and the only thing that's been stopping me is I don't know how to build quadcopters, so I've been kind of waiting until I knew how to start, which doesn't make sense, I agree. So I'm just going to dive right in today using this startup process called minimum viable product. And the idea there is you build a minimum version of your idea that you can experience and get feedback on, and then incorporate that feedback into version 2 and version 3 and build through iteration. So my minimum viable flying thing is going to be this little motor, because I want it to be motorized, and this prop on it, and this battery to drive it all. And that will do something. Mostly it will start me. It'll take about 10 seconds instead of 10 years to start this time. And I will iterate and iterate and iterate until I have something that I'm happy with, or I run out of film. Move it here where we can see it. Oops. Okay, we're gonna put our safety shields down. We're gonna connect this motor, and we're gonna let it go. Okay, new theory. Maybe if we had a straw and a skewer. Not really. A little bit. Go, little man. Whoa. We're gonna use a bigger prop here. Whoa. It's taped on with some minimum viable Scotch tape. Okay, this time 2 pencils, 2 motors, and the motors are attached with fun tack. And go. Away from me. Go. So I'll adjust these a little bit. Oh yeah, that is very nice. Wow. Next up, we're going to try and see if this dollar store foam plane helps. Here's a little 10-cent model airplane, and we've fun-tacked the battery to the side, and we've fun-tacked the fuselage and the propeller together. Very top heavy, very front heavy. Yeah! Whoa! That is crazy. It wants to hurt me. Alright. Battery's off. Whoa! This time we have the motor in a straw. Alright, it's definitely twisting, but let's let it go. Whoa, that flies excellent. Whoa! Alright, this little guy definitely wants to fly. Cut out of cardboard, 4 props, spinning in opposite directions. These 2 big props, they just fly it. They turn in opposite directions, and it should supply lift. Of course, then it's going to rock side to side. So we have these little mercury switches here, and maybe you can see these turning on and off as I tilt it. Off, 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 off. Oh no! All right, timeout. Those didn't work super well, although some of them had iteration potential, I think. I especially like the push-pull one. It was like 2 props and a stick, and it flew remarkably well with a little bit of electronics or control surfaces. I think there could be something there. But at this point, and this is future me, by the way, I decided I should try and build a real quadcopter just so I could approach this problem from the top down as well. And it was remarkably easy because there's this free software online called Betaflight. And all you do is you put it on a cheapo microcontroller, hook up your peripherals like motors and accelerometer, and then you just tell it where those things are, and that's it. It kind of works. So that went really quickly. And then as far as the frame and the balance and everything, the nature of quadcopters is they try and self-balance. So even if you have a terrible frame design, which I did, it will try and do something. So I'm going to go through really quickly how this was built. It might not even make sense here, but I have a ton of footage of how it was actually done. So if you're really interested or even having trouble sleeping, I can definitely throw that in a future video. But for now, let's see how this was built and see if it flies. The way we're going to figure out which direction is up is with this thing called an IMU. You're in a gravitational field on Earth, so you're always accelerating towards the ground. And what it will tell is this thing here. It uses an STM32 chip. They're ARM chips, they're super powerful. That will look like this once we wire it up. And then we go into Betaflight, we can update the firmware. And this is the configuration we're going to use for the accelerometer. And then we will see, even though we don't have motors hooked up, we do have an accelerometer hooked up. Next up is to get the motor and the batteries going. And to do that, we're going to have to use MOSFETs. The reason we have to use MOSFETs is these microcontrollers cannot drive a motor. And you can make a board like this. However, what we're going to do is we're just going to use one we found online. So I picked B0, B1, B10, and B8. This is telling Betaflight that's where the motors are. And now we're going to go into here, take all our motor settings, copy them. We're going to paste this. And now we should be able to test this. We got the microcontroller and the accelerometer and the MOSFETs all fun-tacked to our popsicle stick frame here that's just glued together with hot glue. We got our 4 motors all turning. We do have enough power, and that would be all it took to fly our quadcopter, but we have no way to tell it to start. We have no way to tell it to stop. This is a very tiny transceiver. We'll figure out a pin where it's going to go, attach it, set it up in Betaflight, and then we should be ready to go. So other than the hot glue melting, that worked a lot better than I thought it would. And I think I'm ready to go on to the next step of a more real quadcopter. I think next I'll do a laser cut frame and maybe a circuit board for the actual components and that kind of stuff. But very good learning experience and maybe a very good way for you to get into this. If you do get into this and have any questions, nobody actually watches these videos, so I'll happily try to answer any of your questions in the comments if you have them. And if I don't know the answer, whatever, I'll make one up. All right, we'll see you in the next video.